So, I needed to build a stand for a touchscreen, and also it had to be a speaker, because I want to use this touchscreen device for listening to music and hear voice notifications from my smart home system. So let's see how to use drivers, components and materials that you may find laying in a dumpster and create a practical and cool speaker with a great sound. So this was the original concept I came up with. But of course, having drivers at a 90-degree angle is not very good for listening to music. So I decided to make a column with 2 chambers and drivers will be facing straight forward. Also, I will add ports from PVC tubing in both chambers, you know, for bass. This is not the best configuration for hearing stereo and there may be some problems with phase, but I just don't have the tools to create something with a long and precise angle, and I really want to have a single column, not 2 speakers. So this is the best design I was able to come up with. The aim here was to have a super slim box and a lot of air capacity inside it for better bass, you know, cause I like bass. Also, there will be a tilt to the back. That will make this thing look better with the display on top. And also that will aim the sound towards my ears, since mainly I will be listening while standing or walking around my kitchen. But of course I started this build by choosing drivers and making a crossover. I've gone through my favorite trash sites and found some great options. I found all of these drivers in a dumpster. Some of them are golden, but because of space limitations of my design I could only use the smaller ones. I could place the subs on the sides of this column speaker, but I really don't like that, it messes up the phase a lot. After some time of testing and mixing and matching, I came up with this configuration. So, drivers in the middle don't have a crossover or a bandpass. They're connected in series and they will be producing all of that full range that they can produce. I took them out from old Samsung home theater speakers and decided to use them because they had a very good response in the mid-range, which I like. Lower end is kinda absent, but I will deal with that. Also, the tweeter is from those Samsung speakers. It's just a basic dome tweeter with a 3.3 microfarad capacitor in series to create a high-pass filter. And for the bass, I decided to use this. It came from a computer sound system. The bass response on this little thing is just unbelievable. For this driver I will use a 0.5 mH coil in series and a 32 microfarad capacitor across. That will create a pretty steep low-pass filter, just perfect to make this driver work only in the bass region. The quality of the components I have for this build are not super hi-fi. It's just the usual stuff you may find in speakers. These iron core coils are not the best choice, they add a little bit of distortion to the sound. An air core coil would be a much better choice, but I just don't have enough of those, at least not yet. Same thing goes for the caps. These poly caps would have been a better choice. By the way, this configuration has a resistance of about 5 ohms. Not perfect, I would prefer 8 ohms, but 5 is high enough. And I just don't want to put any additional components in the audio line to make that resistance higher. That will affect the sound in a bad way. Now, I did not use any software to calculate this crossover and try to make a flat response. I did a lot of testing, changing coils and capacitors and drivers, and this configuration was what sounded good to me. Creating a speaker with a flat response is super hard, and also while trying to do that nearly impossible task, you will probably fail to create something you like. Because I think flat response is actually not what most of us like. So do it by listening to your favorite music and comparing your driver crossover configuration with some speaker that you know and like. That is much easier and you will achieve a good result much faster. Tell me in the comments what kind of speaker response you like. Bass heavy or maybe clear high tones. And please subscribe to my channel right now. Anyways, for building the box I found this material in a dumpster behind a carpenter's shop. This is basically strips of pine wood inside some veneer. It's called lumber core. Not the best thing for this, but I really did not have a choice since I'm not buying anything for this project. Well, except some screws. The best material would have been MDF, but the advantage of using that would be marginal in a build like this. So first I cut out all the biggest pieces, just using an old circular saw with a straight piece clamped to the board to keep my cut straight. And this is what I got. Now it was time to create bevels on the faceplate and the backplate for the tilt. I checked from my drawing that a 5-degree bevel will be suitable. And I cut that using a sliding miter saw, since the length of this cut was short enough to do it on a miter saw. First I did the both ends of the faceplate, essentially deciding the overall height of this speaker. And then I cut one end on the back plate. After that I used 3 bevels and a ruler to mark tilted cuts on a sideboard. Then I flipped the back plate and did both sides like that. And also with that I was able to see where exactly I need to cut the last bevel on the back plate, since that was kinda hard to calculate on paper. Then I made those tilted cuts, also with my circular saw. Next it was time to mark screw holes, because I will be pre-drilling those for accuracy, and also trace out speaker positions. This part of the job is very important, cause you may fuck up, like I did, and had to erase some lines. So do use your time to mark everything precisely, so you won't have to make new panels if you mess up while cutting or drilling. Note that it's a good practice to place drivers very close to each other. This way you will get a better response on the vertical axis, basically better overall sound. Next I pre-drilled some holes and started putting this thing together. First I attached the middle board to the faceplate, and here's why. I will be putting braces inside the box. For that I use just a wooden round bar. It's perfect for that, since it will have a minimum effect on air movement because of the roundness. I found this bar also in a dumpster. It came from old kitchen cabinets. These braces will have a massive effect on sound. They will prevent the sides of the box from resonating in a bad way and creating unwanted sounds. So I had to have the sides open first to be able to attach those to the middle board. And after that I used some persuasion to put all of those big boards together in a box. Don't worry, I will glue everything later. That, by the way, is super important to get the box perfectly airtight. That will have a big effect on sound. But first I need to put everything together and then install all kinds of stuff inside. Lining for damping reflections like you see here, and an amplifier, a power supply and whatnot. So I will be taking everything apart at least once. Anyways, here it is without the top and the bottom plates. I'll cut those later. So next I made holes for drivers and ports. When using a jigsaw for cutting round holes, it's good to change your position many times, so you will be comfortable making the turn. This way you will get a consistent and clean cut. Next, follow the long process of rounding those inside edges. I did this to allow better air movement at the backside of a driver. My material is pretty thick, and for example that small base driver has a massive magnet compared to the size of the cone. If the hole is not rounded inside, that magnet will be in the way of air movement. Here's how it looks from inside. Lots of space around the magnet now. This is a good practice to do to increase the efficiency of a speaker. So next, it was time to make the top plate and the bottom plate, and with that I had a challenge. My tools are not that precise, so I was not able to make perfectly flat ground for those connections. I thought about just sanding those areas, but that would create more problems than resolve, since I need a very tight and flat fit all around the perimeter. And then I had a brain fart. I remembered seeing guys resurfacing engine blocks by putting them on a big piece of sanding paper and just rubbing them. So I took a big enough straight board, glued some sanding paper on it, made a handle and put some bricks on top, and sanded like crazy until I had a perfectly flat surface for connecting those last boards. Don't need any gym after that, although those bricks and the gravity produced most of the needed power. Anyways, now I had the box ready and it was time to disassemble it. But there is still a lot to do and share with you. In the next video I will start testing this speaker and adjusting those air ports for just the right bass response. So subscribe to my channel to see my next video about this project. Please like this video. Thanks for watching.